Am I audible, guys? Please confirm if I'm audible. Hello. Okay, so we'll start in 1 2 minutes. We shall wait for 1 or 2 minutes for more students, and then we'll start. Okay, so let's start the session. Again, please confirm if I'm audible. Quickly, please, someone confirm.
Yes, sir.
Okay, fine, fine. So in the last lecture, I gave you several homework problems regarding the AND or implementation and some of the minimum number of NAND and NOR gates required. That was universal gate topic, which was covered in the week 2 session. That was, yeah, this. So let's start the session first. So I'm Anand Singhal, a PhD student from IIT Jodhpur, and I'll be assisting you in solving some of the assignment problems for the course Digital Electronic Circuits, which is taught by Professor Gautam Shah, who's from IIT Kharagpur, and this session particularly prevails for week 3. So here's the content. So as discussed before, in the initial 6 weeks, we'll be covering the combinational part, and at the last, we'll be covering the sequential part. And today, we'll be covering the week 3 topics that involves some of the minimization of a variable entered K-map, and then we have QM algorithm, some of the cost questions, and some of the hazards, which are static 0, static 1, and dynamic hazards. So we'll cover certain questions related to these topics only. But since we left some of the questions in the last week, so I'll start with those questions first. So I hope some of you have done the question. So has anyone done the question? Please respond in the chat box quickly so that we can move accordingly. Has anyone done them? You can write yes or no quickly in the chat box. Okay, fine. Okay, so I'm assuming that all of you have not attended last week's sessions, if I'm not wrong. So let me give you an overview again. So there was a topic of universality of gates. That is, there are several gates which are known as universal gates, which means that we can make any logic out of those gates, and those gates are basically NAND and NOR gates. and we can make any logic using these particular gates. And I gave several homework problems related to that, how many minimum number of gates are required to realize certain expressions. So there are two particular implementations in this AND and NOR gates. One is AND OR implementation, and the second one was OR AND implementation. So I told several shortcuts that whenever you have a AND OR implementation, it will be basically a SOP form, and it will be easily implemented using the NAND expression or the NAND gates. And if we have a OR AND implementation, it will be a POS form, and it will be easily implemented using NOR gates. And I gave an example which was the given question. So we had a question that is, we had a function which is AB plus CD, and we wanted to know that what is the minimum number of NAND gates which are required to realize this expression. So let me give you a brief example here. So if I make the circuit, basic circuit of this particular AB plus CD, say this is AB plus CD. So AB, we are doing the AND operation first, and we are doing a CD. Ultimately, we are doing the OR operations. So this Y will be nothing but AB plus CD. Is there any problem in this particular circuit? Anyone have any problem till now? Please try to respond quickly so that time does not go away. Okay, so if I like break this circuit into two parts, so you can clearly see one of the circuit is completely consisting of AND gates, and one part of the circuit is completely consisting of OR gates. So that is why we call this implementation as AND OR implementation. So now how the shortcut arrives here is, mm, yeah. So what I'll do is, in this particular circuit, I am using two NOT gates in series. So let's say I have a NOT gate and I have a NOT gate. If I give A here, can anyone tell what will be this expression F quickly? Anyone? Yeah, so it will be A, right? So it will act as a buffer. So two NOT gates are equivalent to a wire only. So this is what I have done. I have taken two NOT gates in series here and two NOT gates in series here. So I hope it is clear that the circuit has not changed at all. So now you will see that we have a NAND gate now present here. We have a NAND gate now present here, and we have this gate, which, let's see how does it look. So it is a bubble version of, okay, wait. So it is a bubbled version. So let's say if I give a and B, and let's say it is a Y. So what will be the output expression? Please quickly tell. Anyone? What will be Y here? You can open your mic and tell. So it will be a, yeah,
A complement plus B complement.
yes. And if I make a NAND circuit basic, which has A and B as inputs, and we have a NAND gate, so what will be Y here? Quickly again.
A into B complement.
So A dot B complement, if I open the same, it will be nothing but A complement plus B complement, which is exactly similar to this. So what I am trying to emphasize here is that these both are NAND gates. Is it right? Any doubts here? भाई हंसी आ रही है। इतनी जल्दी कैसे आ गया? कल ऑर्डर करा आज आ गया? सुंदर है। Yeah, so these both are NAND gates, so I can make this particular circuit as, so I'm making it again, I'm using a AB here, making a smaller circuit A, B, C, D, and instead of using that gate, I'm using a NAND gate again. So now if you'll try to solve this expression, it will be nothing but AB plus CD only. Is it clear, this particular part, that how AND or implementation is helping in
Yes, sir.
the,
Yes, sir. Yes, sir.
okay. So the minimum number of NAND gates here required will be 3 only. This I already taught it in the last class, and I gave you now homework problems which were related to, the question were again minimum number of NAND gates you need to find. The problem was, I guess, it was AB plus CD plus EF. The first part was you can use 3 input NAND gates. The second was you can only use 2 input NAND gates. So you can give it a try. The first part is very easy if you try to implement the same logic as given in this, as I explained in this part, and then we shall go to the second part. So try it. Maybe you can take 2 minutes and let me know what are you getting. भाई इतनी जल्दी कैसे आ गया? सुंदर है भी यार, टूट भी नहीं रहा, मस्त चल रहा है। यहाँ पे चिपक गया है ये। नाइस नाइस, थैंक यू थैंक यू। एक दिन में कैसे आ गया ये? बयान नहीं लाई ना? किसी से प्याज दिलवा दो। चाय वाली के पास प्याज भी होती है? आप लाओ। So anybody done the first part? Anyone? So let me give you example. For the first part, it was AB plus CD plus EF, and you can even use 3 input AND gate. So what I'll do is, since we have to make NAND gate, so first I'll focus on making the AND or implementation, because that will be a easier implementation for the AND gate, and it is already in SOP form, so we can proceed by making the circuit directly. So let's say I have a AB, I have a CD, and then I have a EF, A, B, C, D, EF. And since I can use 2 and 3 input gates also, so making this as something like that. So this is the basic circuit, and now I'm again doing the same thing which I did in the last problem, which was I'm using basically two NOT gates in series that will have a buffer effect. So now again we have a similar looking gate as in the previous problem. So let's say this is A, B, C. So that will be A complement plus B complement plus C complement. If I make a NAND gate again, it will be again A, B, C complement, and that will be equivalent to A complement plus B complement plus C complement. So this is nothing but similar to a NAND gate.
Sir, can you please repeat the part of complement?
Which part? This.
Yes, sir. Yes, sir.
Okay. So you can clearly see here we have used three complements. So the input will be A complement, B complement, and C complement. And this is nothing but OR gate. So I'm doing is I'm just using the OR operation for A complement plus B complement plus C complement. And again, if I use a NAND gate which has the input A, B, C, so it will be A, B, C whole complement. Now I can use De Morgan's law, which will give me again A complement plus B complement plus C complement. So here, what I've tried to explain is these both gates are exactly similar, and that is why I've replaced this particular gate with a NAND gate, which is a three-input NAND gate, not a two-input NAND gate.
Sir, can we add one another AND gate in the front of this last one gate? Means see A B C D E F y equal to A B plus C D plus E F. Then please we add one another AND gate. Then it will be make y equal to A B bar plus C D bar plus E F bar. It is possible.
Where to add NAND gate? I don't understand. Here, where are you saying that we can
Uh,
add?
yeah, no, sir. I want to say in the front of holder gates. Yes, yes, here.
Here,
In front of there, we can use another gate, and then we make it y equal to ab bar plus cd bar plus ef bar. It is possible.
so we need to make it AB plus CD plus EF, and we need to find the minimum number of NAND gates here. So this is the criteria. Well, what's the point of adding another AND gate? I don't understand what you're trying to say. So
Sorry,
if I
sir. Okay, my mistake. I am unable to understand the question.
so okay, the question was we need to implement this particular expression using the minimum number of NAND gates. So we have already got. We can even use three input NAND gates. It was clearly written in the question. So we have got. We can only do it by using four number of NAND gates. Is it clear? This particular thing, the question and the objective over it.
Yes, sir.
Okay. So now the second part was a bit trickier. So you can see now you can only use two input NAND gates and you need to again realize the same expression. So quickly try to do the same. Maybe you can take 2 minutes and then we shall discuss. If anybody has got any answer, they can type in the chat box. टाइपिंग कर ली तुमने? बहुत ज़्यादा होते हैं 2 घंटे इनका दिमाग चट मारना. Yes, I've got one answer is 5. So you have used only two input NAND gates, right? So let's check. Okay, so we had two input NAND gates and we had this expression. So So I'm writing it again. We had this only using two input NAND gates. Okay, so I'm getting now 6. Okay, so let's see. I'm making it first of all using only two input gates, that is AB plus CD plus EF. So since we can only use two inputs, so I need to use two OR gates. This is AB plus CD, and then I'll have another OR gate that will give me a AB plus CD plus EF. Now we have this, so we need to apply the same operation here also. So I'm doing the same. I'm using two NOT gates in series. I'm again using NOT gate here and NOT gate here. But quick thing to realize here is I've already made this particular gate as a NAND gate, as we have already discussed in the previous questions. So if I apply a two NOT gate here, it will not remain a a NAND gate now. So instead of doing a NOT here, what I will do is I'll add additional NOT just to nullify the effect of this bubble. So now we clearly know that this is a NAND gate, this is a NAND gate, this is also a NAND gate, this is also a NAND gate, and this is again, and we have an additional NOT gate. Now since we have a NOT gate and we can only use NAND gate, so what we'll do is we can replace this by a NAND gate itself. So let's say I have given A here, so what will happen? The output will be A dot A times whole bar, that will be A complement plus A complement, and ultimately it will give you a NOT gate. So instead of using this NOT gate also, you can, what you can do is you can apply one more NAND gate, and you can do this here and this here. So, do you understand this part, everyone? Any doubts in this? Okay. So we can have 1, 2, 3, 4, 5, and then 6. So the correct answer will be we can make this particular expression using 6 NAND gates. The minimum number are 6. Yeah, so these were the problem. Now I'll quickly move to the NOR gates. As I have told you, there are two types of implementation. One was AND OR, and second was OR AND. And this OR AND is POS, and this will be easily implemented using NOR gate. So I'm doing the same now. We have a expression A plus B times C plus D. So this is a POS form. So I'm using OR AND implementation now. So we have A plus B, then I have a C plus D. So this is A, B, C, D, and this will be Y, which is A plus B times C plus D. And we again quickly doing the same thing, doing two not. So this is a NOR gate, this is a NOR gate, and we just need to check this particular gate, which is something like this. So this is AB, so this will be A complement dot B complement, and NOR gate will give you AB. It will give you A plus B whole complement, that will be equivalent to this again. So this is again a NOR gate. So we can do or make this expression of NOR gate using three NOR gates. Is it clear? Any doubts in this?
Sir, last time repeat, sir, please.
Okay, so what I'm saying is again I'm doing the same circuit using OR and implementation because it was the POS form, and again I place two NOT gates in series that will give you a buffer. So this is a NOR gate, this is a NOR gate, and this is some gate which I have proved that this is equivalent. Again, if I give input as A and B, this is A complement multiplied by B complement, and if I use the same input as A and B in a NOR gate, it will give you A plus B whole complement, and that is equivalent to A complement times B complement. So these two gates are equivalent, and I have replaced it with another NOT gate, another NOR gate. So again, the answer will be 3 here. Is it clear? Quickly let me know the answer to this now. Let me give you some here plus GH, and you can only use 2 input NAND gates. Let me know the answer in maybe 2 minutes. Yes, I've got an answer as 9. So let me quickly do it. So we have AB, CD, some are saying 8. Let's see. A, B, C, D, E, F, and this is GH. Since I can only use, sorry, 2 input OR gates, so I'm doing 1 OR here, sorry, one more OR here, finally one more OR here, and this will give me the given expression, which is, let's say, F. And again doing the same thing, I can use a bubble here, bubble here. This is fine, nothing is wrong here. I can use bubble here, but to use a bubble here I need to add additional AND gate here. Similarly, I can use a bubble here and a bubble here. Now to add an additional bubble here, I can again use an AND here. So let's count now. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So those, some of you have got 8. Is it clear now? Fine. So you can take few homework problems for next lecture. So let's say this was easier because you can already see that it was already implemented in a AND or implementation. It was directly given and you need to do it using NAND. So let's say if I give you a
Uh,
problem,
sir, please to scroll up.
sorry, okay,
Sc-
this,
uh, sc- okay, okay, sir. Yes.
okay. So instead of you giving you directly the AND or implementation, if I give you W plus X, let's say, and Y plus Z. So now this is a POS form, and now I'm asking you again. So minimum number of NAND gates. So let's try to do this particular problem here only. You can only use 2 input NAND gates. So quickly let me know the answer. One thing you need to remember is NAND is only easier using AND or implementation, not OR AND. So try to do the same using shift logic and then let me know. You can take 2 minutes again. So let me make it easier for you. Let's say I've given you w complement plus x complement instead of w plus x. Now let me know the minimum number of NAND gates. So please take some attention. I have changed the question. So it is w complement plus x complement times y plus z. तुमको कुछ बनाने को नहीं मिल रहा तो तुम खाली बैठी हो. Got one answer is 5.
Yes, 5.
No, even let me give you some options also 3, 4, 5, and then so some other people are saying 5. Any other answers? So let's check quickly what is. So now this is w complement plus x complement times y plus z. So first of all, we need to convert it using in the SOP form. So if I try to do it directly, let's say this is f. So it will be something w complement y plus w complement z plus x complement y and x complement z. So this is not optimal. You can clearly see this is a long expression, and if you apply the same, it might uh, give you some wrong answers or more number of NAND gates. So what I'll do is I'll use a trick here. So let's say I have been given w complement plus x complement times y plus z. If I say this particular first term is w complement plus x complement, so my f will reduce to p times y plus z. That will be py plus pz. Got one more answer 7. So let's see. Is there any doubt till here? I have just assumed one variable which is w complement plus x complement as p. Is it clear till here? Any doubts? Okay. So now if I make this circuit now, because it is AND or implementation, so what I will do is I'll make y py, so p is common basically. This is z py plus pz. So this will be or. This will give me expression of py plus pz. Is it clear? Any doubts? Please respond quickly. So now I have a p of w complement plus x complement. So what I'll do is I'm using a w and a x and a NAND gate here. So my expression will be, let's say it is maybe q. So this will be nothing but w dot x whole complement, and that will be w complement plus x complement. That is my given p, right? So if you now clearly see, or please be attentive. So I'm again making the same circuit. So this is y, this is z, and instead of using p directly, I'm using w and x using a NAND gate, and then I'm again making the same circuit above. Let's say this is f, and again doing the bubble thing. This will be bubble. So what will be the answer? Anyone? Is there any doubts in this particular circuit that I have made? Why 5? It is 1, 2, 3, 4. So you can take problems that will help you. So let's say I give you a problem which is, then I will give you W plus X. You need to find NAND gates only, 2 input NAND gates. You can tell me the answer in the next lecture for these problems. Please note down these problems. Let's proceed now. So quickly let me know the answer to this now. Then we'll move towards the topic of this week. You need to find minimum number of NAND gates to realize two variable XOR gate. An XOR gate is something A B complement plus A complement B. Or we can write this as A plus B complement A complement plus B. A B, sorry. So this is not correct. You can write this as A plus B A complement plus B complement. Quickly let me know the answer in 2 minutes. Okay, so we'll see maybe in 1 minute if others are also answering. Some answers are 5. So let's try the same. So since you can see there is complication, so let me try to give you a quick answer directly. So I made a circuit. I'm just evaluating the same now. So this is A, this is B, and here the input is A complement plus B complement. So we're using the notation G, H, and F. So G will be A times A complement plus B complement whole complement, and that will give you A dot B complement, that is A complement plus B, and I have a H that will give you B dot A complement plus B complement, which is equivalent to A plus B complement. And now I have a F which will give you A complement plus B A plus B complement times whole complement. This will be A. Sorry, I've written something wrong, I guess. Yeah, so this is, yeah, this is the whole complement. This will give AB complement plus A complement B. So, is there any doubts in this? How I've reached this? Everyone agrees that F is this. So the correct answer will be 4. So let me quickly give you a table so that you can remember. Oh, let's say minimum number of NAND and NOR gates, and we have our expression we can make not, or sorry, let's see, this is and XOR XNOR and NAND and NOR. You can remember this table for shortcuts. So minimum number of NAND gates are 1 2 3 4 5 1 4, and here it is 1 3 2 5 4 4 1. So basically, if you remember this part, then these are getting inverted in the node. So what I'm trying to say is, we need, let's say we need 4 NAND gates, minimum 4 NAND gates to make a XOR, or we need 5 NOR gates to make a XOR minimum, or I can say we need 4 NOR gates to make a single NAND gate. So please try to remember this table. It will help you in solving the problems quickly. So let's move to this week's problem now. So maybe you can try it first. I can give you 2 minutes and then let me know the answer so that we can proceed. Okay, so I've got one answer. Let's wait for some more answers and then I'll solve. एक घंटे से भी ज़्यादा भाई, अभी तो बचा वहाँ। प्यार लिया यार कहीं से, उनसे पूछो. So let's solve this problem. So this is a basic problem in which we have a main term expression and we need to minimize the boolean. So we can use several methods such as conventional or standard canonical methods, but I'll use the K-map because that will be quicker. So I'm making the K-map. This is 0 1 2 3. Now I have one set 0 1 3, sorry, 3 5 7 8 9 11 13 15. So we can have four things in a KMF, that is octet, quad, pair, or a singlet. So what will be the number of all these things? Can someone quickly tell that they are getting? Anyone? Is there any octet in this? Okay, one octet. Then any quad? So what I can see is clearly there is an octet which is this, and everyone is covered now except these two. So we'll try to cover it by a maximum value. So there will be one quad. So there will be no pairs and singlets. So let's quickly let find the answer here. So it will be this will be D and this will be D, and this particular thing will be B complement, and this will be C complement. And yeah, so option
Sir,
B is this.
unable to understand the lines means when you selected one, C bar D bar and C bar D, but I am unable to understand. Sir, please can you please repeat?
Which part you are not able to understand?
Sir, V bar, ever V bar C D. When you select the parts na?
Yeah, like why I've selected these.
Yes, yes, sir.
So we need to find the maximum number of values. So there is a priority chart kind of thing. So we need to first check if there is any octet possible in the given expression or the given K-map. Then we'll check for quad, and then we'll check for pair, and then we'll check for singlet. So first of all, I checked if there is any octet possible. Octet means a continuous a continuous combination in which all the 8 ones are covering. So I saw that there is a possibility of 8 ones that are getting covered, which is in the middle of this K map. Then I was left with this one and this one. Now I need to check whether I can make it either using, let's say, either using a pair, which is this particular thing, or this particular, okay, wait, or this particular quad. So I need to cover everything using the maximum priority. So that is why I took this octet first, and then this I have covered it with the quad. Oh, so yeah, with the quad. So that is why I got the minimized expression. Okay, so there is one more doubt. Can't we take two quads and two pairs? Where can we take two quads? Can you please elaborate your doubt?
Yes, sir. First four ones and other four ones in the same row,
Okay,
and two
wait.
pairs at the
So you are saying
like
these
1357,
something like this?
1357 boxes, sir.
One, 1357. Okay, and another one,
And another 13, 15, 9, 11. Can't we take like that?
and another is 13, 15.
Yeah,
Okay,
that way.
so we have already made two quads, so you can clearly see this is a octet itself. We need to cover the
Yeah,
maximum.
that separates.
Yes.
And we take separate two quads.
So we cannot take, so okay, so let me give you a basic idea. So let's say if you take these two, so this will give out, this particular quad will give out A complement, this will be
D
D,
plus
and this
AD.
particular quad give out A and then
D.
D, right?
Yeah.
So if I take
Yes.
common D from this, it will be A plus A complement, and it will again give me a D.
Okay.
So that is why we need to take the maximum possible combination.
Okay, sir. Thank you.
Yeah. So now try to do the same question. So this is again a similar question. So quickly let me know the answer to this. You can take 2 minutes, everyone. यार इंतजाम कराओ क्या बोल रहा हूँ, प्याज का इंतजाम कराओ। उसको बोल दो फोन करके, जीतू को, तो प्याज दे दे भाई। मेरे फोन में होगा। फ्री कल सुबह कितने बजे निकलना है? 8:15 की ट्रेन है। प्रथम भी जा रहा है ना? बोला तुमने उसको? हाँ, क्या हो गया? नहीं नहीं, मैं म्यूट कर रखा हूँ। उसमें देख लो, मतलब इस वाले कंप्यूटर में। मैं तो एक एक वर्ड के कैप्शन लिखे हुए। यार मजाक मत करो यार। नहीं नहीं, आप यहाँ मत बैठो। मैं चाहता हूँ दो वो आए, एक ही वर्ड के कैप्शन है भाई मेरे। हाँ तो मेरे को भी वैसे ही बनाना है। मैं सोच रहा हूँ कि मैंने से एक में 4 लाइन लगाई ना, मज़ा नहीं आ रहा है। हाँ अभी आएगा खुल के। मुझे अभी कुछ बोलना मत। सी 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 है क्या आंसर इसका? क्या आंसर पता नहीं मेरे को। अभी आएगा खुल के। यहीं पे खड़े रहोगे क्या? थोड़ा उधर जाओ, मैं कैमरा खोलने वाला हूँ। तो क्या हुआ, मैं भी दिख जाऊँगा पीछे डांस करता हूँ। कुछ मत करना। Okay, so let's check the answer. Again, I'll use the K map. This is A complement, D complement. This will be CD. 0, 1, 2, 3. So let's fill it out. So we have 4, 6, 7. Then we have 10, 11. Then we have 12, 14, and 15. So again, we'll check with the same priority: octet, quad, pair, and singlet. So quickly let me know these numbers, anyone. Anyone? The quads you are getting. Okay, so let's see. Anyone else with any other suggestion? So 0300, something like that. Okay, so let's see. So one quad can be this. Okay, now I need to make two quads out of here. So yeah, it will be three quads and nothing else. So the answer will be, for this quad it will be B, C. For this it will be A, C. For this it will be B, and then D bar. Yes, so option C is correct. Any doubts in this? Any doubts?
Oh, sir, can I ask a question?
Yes, yes.
Sir, I am in this type of question. I am unable to understand when we consider 0 1 then 3 then 2 then 4 5 7 6 means I want to say this is not a line exact line, but when then after after 7 then we get 12 13 15. Can you please
Yeah,
explain?
so this is a K-map. You might have learned in your theory classes that a K-map works on a gray code basis. This is basically 0, 1. So this 3 is a gray code for 2. This 2 is a gray code for 3. Uh, you need to cover the basic K-map classes. So this K-map works on the gray code, and you need to learn that we need to fill it on the basis of gray code, and that is why we write here 0 1 2 3 instead of 2 3. We change the gray code binary digits. So that is why I have written 2 here and 3 here. Similarly, we have 4 5, and then this is a gray code for 6, and this is a gray code for 7. So that is why I have written it simultaneously. Then 6 7 instead of 6 7, I have written 7 6. So you need to check the theory classes for K-map. This is works on gray code. If you still have any doubts, you can mail me, then I'll cover your doubts for this particular thing, because this is a basic thing in the theory classes. So if uh, so now again a similar question. So we have been given a POS expression, that is this, and we need to find the equivalent SOP expression. So quickly let me know the answer. This is very basic. You can take 2 minutes. कहाँ हो गया? Hmm. So I've got one answer as B. We'll check if this is correct. Anyone else? So let's check. This is a POS form. I'm writing it. So we need to convert it to its SOP form. So we can either use a conventional way, we can directly solve it. It will be, if I'm just opening the bracket, it will be xy plus xz, x plus y plus z. Sorry, I was on mute. Am I audible now? So it is xy plus xz, and then it is getting multiplied by x plus y plus z. So I can write this as, I'm just opening each and every term. So first term will be xy, the second term will be again xy, third term will be xyz, fourth term will be xz, fifth term will be xyz, and the final term will be xz. So again xy is common, so this is xy, xyz is common, this is xyz, and then xz is common, so this is xz. So yeah, this is C. This was quite easy. Is it clear?
Sir, when we write here xy double two times,
Sorry, okay. So I told you in the previous class that if you add a similar variable two times, it will give you the variable itself. Like there were some properties, such as if you add a variable with a 0, the variable will be the answer. If you add a variable with a 1, then 1 will be the answer. Similarly, there were several properties for AND operation. If you multiply a variable with a variable, the answer will be that variable only. You just need to apply. You can check the truth table by making these things, so you will get to know. Is there any doubt? Fine. Okay. Now there is one important concept of essential prime implicants. So there are two terms. Basically, one is prime implicants, and second is essential prime implicants. So let me give you a basic definition to this, and then we'll find out what are these things. Give me a moment. Yeah, any doubt? Yes, Shushmita, is there any doubt? Okay, I hope it is done by mistake. So prime implicants is basically total number of ones that are present in a K-map, and essential prime implicants are minimum basically, or all number of pairs slash quads slash octet that are necessary to realize a given function. Is there any doubts in these definitions? So let me give you a basic example. So this is the example in which we have asked for essential prime implicants. So first of all, what are prime implicants? All the number of ones. So this particular figure has 1, 2, 3, 4, 5, 6, 7. So pi will be 7 directly, and now we need to find the essential prime implicant. For that we need to find the maximum number of chords pairs that we need to realize this expression. So can anyone tell what are the number of chords pairs? It is clear that there is no update. This implicant, yes, implicants and prime implicants are the same thing, but we always say it as prime implicants. So quickly let me know this number. What are the number of chords pairs and singlet that we are getting? Anyone? Okay, so one is getting four pairs. Any other answer? So I'm getting one quad, three pair. I can clearly see there is a quad. This is a quad. And then one, two, three. Yeah, so there will be three pairs and one quad. So since there are four number of pairs and quads required, so the EPI will be four. Is it clear? So this is the basic concept of prime implicant. So let's move ahead. Okay, so now this is a concept of five variable K-map. Uh, so for five variable K-map, there is a concept that we can make a K-map. So we need to separate the first entity. So please try to listen carefully. So we need to separate the first quantity in terms of A and A complement. So we generally make two four variable K-map to realize a one five variable K-map. Is any doubt? Uh, Someone has raised the hand. Any doubt? Not, so I'll continue. So this basically we have five variables. So you can clearly see we have A, B, C, D, E. So the first K map, sorry, is reserved for A complement, and the second is reserved for A. And we will just make the K maps for the rest of the terms, that is B, C, D, E. So this will be B, C. Sorry, this will be D complement, E complement, D complement, E, D, E, and DE complement. So this will be similar for this. Now the numbering will be exactly same as we did 0, 1, 2, 3, 4, 5, 6, 7. After 15 we will have a 16 here, sorry, 16, 17, 18, 19, and it will go on exactly the same way. So this will be, sorry, again 20, 21. This will be 24. Any doubts still here? Please respond if you have any doubts till now. Any doubts? So now we'll just fill the terms which were given. So 2, 3, 6, 7. 3, 6, 7. Then we have 10, 11, 14, 15, 10, 11, 14, 15, 18, 19, 22, 23, 26, 27, 30, 31. Now we'll see the same quads, octets, and pair as we see for a four variable K map. So we can clearly see both of them have basically two octets which are getting covered singularly. So whatever answer that we'll get, it will get multiplied by A complement, and whatever answer we'll get from here, it will get multiplied by A. This is how you solve a five variable K-map problem. So I'm just solving the same. This particular thing is D, and this particular thing will again be D. Sorry. Yeah. So we have a complement times d plus a times d. I can take the d common. A plus a complement will be 1, and finally we have a d. So this whole particular k map is getting reduced to d. Is there any doubt in this? Please ask straight away if there is any. This is an important concept. You might get several problems by using a 5 variable k map in your assignments. So is there any doubt? So fine, if there is no doubt, so try to solve this. This is again a 5 variable k map problem. You need to find the minimized expression. You can take 2 minutes. भाई क्या चुरा रहे हो मेरा आइडिया? नाम लिख दो। क्या नहीं आ रहे? देखो नहीं समझ में आ रहा। सब फिगर का एक ही कैप्शन होना चाहिए। तो उसमें दिक्कत क्या आ रही है? किसी एक फिगर में कितनी लाइन है? सॉरी, एक लाइन में कितनी फिगर है? तो वहाँ पे कहीं पे लिखा होगा अंडरस्कोर टेक्स्ट विड्थ, उसके पहले 0.33 लिखा होगा। ढूंढो लेटेक पे 0.33 को 0.25 कर दो। 0.6 लिखा है। अरे 0.6 इंटू टेक्स्ट विड्थ ऐसा लिखा है। आप बोले ना, आपने मेरा कॉपी करा ना, तो 0.6 लिखा हुआ मेरे में, तो उसको 0.25 कर दो। 4 बार होगा ना आपका, जैसे 0.6 0.6 0.6 0.6, तो चारों को 0.25 कर दो। नहीं, 0.24 कर दो चारों को। हाँ, फिर एक लाइन में वो 4 हो जाएगी, सबके कैप्शन अलग अलग हो जाएंगे। हाँ, 0.4 है, तो सबको 0.25 या फिर 0.24 कर दो सबको। हाँ, 4 बार लिखा होगा ना वो, तो सबको 0.24 कर दो 0.4 की जगह। हाँ, तो दो नहीं आएंगे ना अभी। 0.24 2.24 0.24 0.24 करो, आ जाएंगे। अरे यार, ओ हटा दो हटा दो, अभी करता हूँ, सही रुक जाओ। एनी आंसर? So let me solve the same simultaneously. So I'll make the k maps again here only. This will be for a complement. This will be for, so I'll do the numbering again quickly. No one has got any answer. So now again we'll fill them quickly, which is 0, 2, 8, 10, 0, 2, 8, 10, 11, 13, 16, 18, 24, 26, 27. And we have don't care for 5, 6, 9. We don't care for 5, 6, 9, 14, 21, 22, 21, there is 22, 22, and 30. So please let me know for the first what are the number of, I guess there is no update. So what are the number of quads and pairs in the first one, and then similarly for seconds. Anyone? 29 is also a min term. Okay, 29. Yeah, yeah, sorry. Thank you for clarification. So what are the quads and pair in the first term or the first box? Let me try the same. Any answer? Should I solve? For the first box, I can clearly see there are two quads possible. One is this, and yeah, so one will be this. And since this is don't care, so this is the only pair I can take. So for the first term, it is coming out to be A complement times BC complement. Second, sorry. The second is E complement and C complement. C complement and E complement. Sorry, there is one more term. And the last is C D complement E. Is it fine for the first part?
Sir, can we take 2, 6, 14, 10 as one part?
2, 6, 14, 10. Okay, so try to see clearly. We should always consider don't care after we have not filled the all the ones. So I've already taken all the ones as this quad. So we don't need to
Okay.
take this again. That will be a redundant term. So that is why
Okay,
I
sir.
have not
Thank you.
taken it. So similarly for the right one, I'm taking similarly the corner ones. Yes, both looks both are not similar, and I'm taking this. It's 27. Okay, so I have not written this correctly. This is not 1. This is 29. So for the second term, it will be A times what was it? This will be C complement E complement, and finally we have this particular thing which is C and D complement E. So you can clearly see these two terms are same. Are same means if I take common C complement E complement, the first term will give me a plus A complement. Similarly, C D E complement will give me a complement plus A complement, and the additional term is A B C complement. Is there any doubt in this? The way I have written it? I have taken C complement E complement common, and the common factor was A plus A complement. Similarly, for C D complement E, the common factor and the first term remains the same, which is A complement B C complement. So if there is no doubt, so the first term is C complement E complement, the second term is C D E complement, and the third term will be A B C complement. So this will be the final minimization, I guess. Is there any option? Something like this. C complement E complement. I guess there is more minimization here. Okay. Is there any option? A, B, C complement. But written something wrong.
Sir, first one expression is wrong.
Okay, so let me again check. So this is a quad. So this will give me C complement and E complement. This is fine. Then this is a single pair. This is also fine. This is the only thing left. And this I can write as B C complement. This is what I have written. Acha. So this will be A complement B C complement. A complement B C complement. So A complement B C complement C complement E complement and one is C D. Yeah. So option D we have. Is there any doubt in this? Please let me know if there is any doubt.
Explain first one part
Okay.
expression, sir.
So the first quad that I've taken, let me use some, is all the ones in the corner that will give me C complement times E complement. So this is this. Then I've taken, since there was a one remaining here, so I've taken this quad which will give me A complement times B C complement, which is this. Sorry. And this is I have a pair that will be C D complement E. This is the first expression, and these two are same for the second one. So that is why these two look similar, and since these two are same, so A will get cancelled out because of the A and A complement. So these two will be in the final answer directly. And the first point was A complement B C complement. That is the final term, and which is option D. Is it clear?
Yes, sir.
Okay, fine. So let's proceed now. Okay, so there are topics in this particular lecture for cost criteria. So now there are few problems related to the same. So in this particular question, you need to find the total cost using this output minimization method. So let you know the direct formulas for that. You have been given several expressions. One is F1, one is F2, and then you need to check the total cost. So like you need to get the realization first, and then I'll give you the formula. So the total cost is equal to the total gate cost plus the number of gate used. And this gate cost is now equal to the literal and the terms cost. So literal means total number of literals, and literals are nothing but this A, B, C, D. These are all called literals, and these are total number of terms. So first we'll calculate this gate cost, and we'll apply the same, and we'll see how many number of gates are required after that, and using that we'll calculate the total cost. So for calculating all of this, we first need to realize this F1 and F2. So quickly make a K-map and let me know what are the expressions that are coming for F1 and F2. I'll write F1 again maybe here. F1 is main term 0, 1, 10, 13, 40, and we have a don't care of 4, 5, 12. Similarly, we have F2 which is main term of 5, 8, 9, 10, 30, and I don't care of 6 and 40. So I'll also make the K maps. What is the term? A, B, C, D, S. This will be A, B. So I'm making the first one. So if you have got the answer already, so let me know the answer, the minimized expression. So it is 0, 1, then I have a 10, 30, and a 40. Don't care is 4, 5, and 12. 12 is over here. Similarly, I make for F2, not writing it again. It is 5, 8, 9, 10, 30. So 5, 8, 9, 10, and 13. And 6, 4 are the don't care. 6 and 4.
14, sir.
Sorry.
6 and 14 are don't gives.
Okay, fine. I've written 4, 6 and 14 are don't care. Yes, sorry. So what the first output will be, I'm writing directly. Okay. So I guess I can directly write these pairs, which will be A complement, B complement, C complement. This will be B, then C complement D. The third will be A, C, D complement. Similarly, here I can use this pair, and I can use this because this is not getting redundant. So F2 will be A, B complement, and then the bottom is C complement. These two will be same, so I'm writing B, C complement D, and the corner one is A, C, D complement. So
Sir,
these, yeah,
sir, can't we use quad using don't care, sir? That
sorry,
means 0,
yeah,
1,
yeah,
4,
okay,
5,
yes, yes,
and 4, 5, 12, and 13.
okay.
Is it correct or wrong, sir?
It will be fine if we can use the quad.
Okay, sir.
Let me give you a like make you understand the first of all the total cost and gate cost regarding this expression only, so that you can try to get all these functions, and then we'll see how we are getting it for the basic quads. So these are the expression in which basically these two are common in both the terms. So first of all, we'll calculate the gate cost, that is the literal and the total number of terms. So literals we need to find only for those particular things which are not basically which are not common. What I'm trying to say is this is common here and here, these are common here and here. So we don't need to count them twice. So we only will only count them once. So the total literals are, sorry, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Since we have already counted these, so the total literals are coming out to be 12, and the total terms are directly, you can see these are 6. So this is how you count the gate cost, that will come out to be 18. And now you need to find the total cost, it will be the gate cost plus total gates used. So 18 plus 18 will be 22. 22 plus 22 will be 32. 32 plus 32 will be 34. 34 plus 32 will be 36. 36 plus 32 will be 38. 38 plus 32 will be 40. 40 plus 32 will be 50. 50 plus 32 will be 60. 60 plus 32 will be 70. 70 plus 32 will be 80. 80 plus 32 will be 90. 90 plus 32 will be 100. 100 plus 32 will be 200. 200 plus 32 will be 300. 300 plus 32 will be 400. 400 plus 32 will be 500. 500 plus 32 will be 600. 600 plus 32 will be 700. 700 plus 32 will be 800. 800 plus 32 will be 900. 900 plus 32 will be 1000. 1000 plus 32 will be 2000. 2000 plus 32 will be 3000. 3000 plus 32 will be 4000. 4000 plus 32 will be 5000. 5000 plus 32 will be 6000. 6000 plus 32 will be 7000. 7000 plus 32 will be 8000. 8000 plus 32 will So gate cost is 16. Then the total gates used are, you need to check from the single expression. Sorry again. So from a single expression, you can see there are two OR gates required and two AND gates required for each and every particular term. So what you can write is, give me a moment. So there will be one, sorry, my bad. There are four plus expressions, and for each of them we have two AND expressions. So I can write four OR gates and two AND gates for each and every term. That will count to be 24. So do you understand the concept of this? How I get 12, 6, and finally this total gets used. This is a particular motive of this particular problem. How to count them. Is there any doubt? You can ask straight away if there is any doubt.
How to count hand gates, sir?
How to count?
Hand gate.
Okay,
Hand
AND
gate.
gates are count by, see, you need to pick particular term and you need to see amount of AND gates or amount of AND operation in that particular term. So each and every term has two AND gates. I mean the requirement of two AND gates. Basically, what I'm trying to say is this is A complement, B complement, and this is getting C complement. So that is why 2 and 4 OR. And this is the gate cost, which was 12 plus 6. You will get the idea. Basically, I guess I have more questions. Yeah. So try to do this. If you not get the idea, then I'll try to explain this particular term. So again, you need to count the gate cost here, not the total, but the gate cost. First of all, without counting the NOT gates that we did in the previous problem also, we did not count these NOT gates in the previous problem. So now, first of all, try to do the same. And the second problem is with NOT gates. So there is one term G, there is one term Gn. So first of all, let me know the minimized expression to this particular term. So clearly see this is a max term problem. So quickly let me know what are you getting. Then we'll see what is f you are getting. Then we'll proceed to the problem. You can take 2 minutes and let me know the expression. So since we have less time, so let me also do it simultaneously. So we have a max term. So I will write the KMap using max term now. Really, this will be writing it quickly. Prefer that. Yes, so it will be uploaded on the YouTube. By today only it will get uploaded on the YouTube. You can search this on YouTube. So again 0, 1, 2, 3, 5, 6, 7. We have 0, 1, 4, 7. So since this is max term, so I'll write 0, 4, 7, and then 10, 11, 15. I don't care. So what will be the expression here? Okay, so I guess this is the only possibility that we have three pairs. Please correct me if I'm wrong. This will be A plus B plus C. Second term will be A plus C plus D. Third term will be B complement plus C complement plus D complement. Are you all getting the same? Any doubts? Please quickly respond. Okay, so now again we need to find the first of all the gate cost without counting the NOT gates, and one is gate with counting the NOT gates. So again we'll do the same thing, literal plus sorry, this will be literal plus terms. This will be literal plus terms plus NOT gates. So literals are again one, sorry. Okay, pardon, I guess it got vanished. So I'm writing the what I got again. This was A plus C plus D, and finally it was A complement plus B complement. Sorry, this was B complement plus C complement plus D complement. So I'm writing the gate cost now. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 literals because nothing is common. Then we have 3 terms. So this will be 12, the direct gate cost. And if I count the NOT gates also, so it will be same, the gate plus literal cost. Sorry, the terms plus literal cost, and there are 3 NOT gates you can see required. So it will be 15. So option A will be correct. Is there any doubt? Anyone have any doubts in this? Fine. So there is one more topic that is left to cover now, which are hazards. There are 3 types of hazards basically. One is static 0, one is static 1, and the third one is dynamic hazard. So I'll let you know when does this occur. So whenever you are getting a term like x times x complement in your expressions, a static 0 hazard can occur. Similarly, whenever you are getting a term like x plus x complement in your particular realization, then a static 1 can occur. For dynamic, you need to have a term like x plus x complement. So these are the 3 types of hazards that can occur in a circuit. So I'll give you the explanation, sorry, some of the examples here. So let's see, in this given question, it is given that f is given by x plus z, y plus z complement, and then g is also given, which is yz plus xz complement. So for the first part, that is f, if I take x equals to y is equals to 1, then f will be, can anyone tell what will be f if I take this condition? And similarly, g if equals to y is equals to 1. Anyone, can anyone tell quickly? Anyone? Okay, so I just put it 1 plus z and 1 plus z complement. So it will be nothing but z complement, which will be 0. But you can see we have a term which is similar to x times x complement. And similarly, if I do it here, it will be 1 z plus z complement, which will be 1. But we have a term which is equivalent to x plus x complement. So for F, you can clearly see we have a term which is Z complement, so static 0 hazard occurs. And for G, we have a term Z plus Z complement, so static 1 hazard can occur. So for F, we have static 0, and for G, we have static 1. So option B will be the correct answer. Is there any doubt? Please let me know if it is clear. Fine. So if it is clear, so let me know the answer of this quickly. Or maybe you can do a easier question first. This is more easier. So let me know the what kind of hazard occur in this given circuit. You can take 2 minutes and quickly let me know the answer. This one answer is no hazard. So let's see. This is basically Z complement. This is X, this is Y, and this is Z. This is AND, so this will be XZ complement. This will be YZ. So the final F will be XZ complement plus YZ complement. Oh, sorry, plus YZ, right? So let's say if X is equals to Y is equals to 1. So what will be F? Can you tell quickly? So it will be Z plus Z complement. That will be 1, but we have a static 1 hazard, right? Is the doubt clear? Musa has said D. The answer will be static 1, that is B. Is it clear? Fine. So now quickly let me know the answer to this. So we have expression. We need to tell the hazard that can happen in this. So take 2 minutes and let me know the answer. So this the given expression is A plus C complement and then B plus C times CD. You can clearly see if I use A is equals to B is equals to 0, maybe D also 0. It will give me C times C complement. That will be a static 0 hazard. If I use A as maybe A as 1, B as 0, sorry, not A as 1, and then sorry for the glitch, then C as, sorry, not C, D as 1. So what I'm getting is C times C complement plus C. This is a dynamic hazard now. And for finally, I want C plus C complement. So if I use B as 1, A as 0, B as 1 and D as again 1, you get C complement plus C. That will be a static 1 hazard. Is there any doubt in this? So I'm getting all the hazards in this particular expression. That is 0 also, 1 also and dynamic. So option D will be correct. Is it fine? So we are running out of time. So this is a basic formula based question. So for a n variable Boolean logic, we need to find the minimum and maximum number of EPIs that we have already done using KMS. So this is a direct formula. So minimum EPIs are always 0 and maximum EPIs are always 2 raised per n minus 1. So you can use this formula whenever asked uh, in any question. So correct answer will be B. This is a formula based question basically to let you know that what are the minimum number of EPI and maximum number of EPI that are possible for an n variable Boolean expression. I hope this is clear because this is very easy, and if it is clear, so let me know the answer to this. It says for a 6 variable Boolean logic, the minimum and maximum number of EPIs. So n is 6, basically the minimum EPIs will be 0 only. The maximum EPI will be 2 raised per n minus 1, that is 2 raised per 6 minus 1, which will give me 2 raised per 5, that is 32. That will be option B. Is there any doubt in this? Fine. So I guess we have covered almost each and every topic. So let's go above. So yeah, so we have covered minimization also. We have covered QM algorithm, that is a variable entered KMA. We have covered the cost topics also and the hazards also. So this was all for week 3, and we have also covered these topics, and I have given you several homework problems that were, I guess, somewhere here. Yeah, so these try to do it before the next lecture and let me know the answer, that the minimum number of NAND gates here, 2 input NAND gates required for these expressions. So first we'll do these and then we'll move to week 4 topics that are related to, I guess, multiplexer. Yeah, so there are several circuits now that we'll cover in the next week, and then we'll frequently move forward. So is there any doubt, or we shall stop the session now and we'll meet at the next week at the same time? So please let me know if there is any doubt. Anyone? Fine, then we can dismiss the session. So we shall meet at the next week for the same time. That is Tuesday at 6 p.m. to 8 p.m. Thank you, everyone.